In an underground workshop beneath the ruins of Kokura Arsenal on September 3, 1944, a submachine gun that looked vaguely like the legendary American Thompson exploded during its 47th round of testing, sending the bolt assembly flying backward with such force that it shattered against the concrete wall and set fragments into the face of test shooter Sergeant Tanaka Yoshio, blinding him in his left eye. The weapon, Japan's frantic attempt to replicate the firepower that American Marines were using to devastating effect across the Pacific, had just disintegrated, revealing that 6 months of desperate work under constant bombing had produced nothing more than a lethal failure. As Tanaka screamed and blood poured from his face, Chief Engineer Nakamura Hiroshi realized that his country's industrial infrastructure was so degraded by war that they could no longer manufacture even copies of enemy weapons, let alone match them. This is the story of Japan's final futile attempt to close the technological gap that was destroying their empire.
The Tommy gun that terrified an empire. The Thompson submachine gun, the Tommy gun, had been terrorizing Japanese forces across the Pacific since the earliest days of the war. Designed by General John T. Thompson in the aftermath of World War I and manufactured by Otto Ordnance Corporation, it was a .45 caliber selective fire weapon capable of firing up to 800 rounds per minute from stick or drum magazines. The Thompson's distinctive profile, its round receiver, vertical foregrip, and often the large drum magazine, had become iconic in American culture during the Prohibition era, when it was wielded by both gangsters and lawmen. But in the jungles and islands of the Pacific War, it was proving to be a devastatingly effective close-quarters combat weapon. By late 1943, Japanese military intelligence had compiled disturbing reports about American firepower advantages in close combat situations. American Marine and Army units were equipped with submachine guns at rates that Japanese forces couldn't match. A typical American infantry squad might have 2 or 3 Thompson submachine guns, supplemented by M1 Garand semi-automatic rifles and Browning automatic rifles. Japanese infantry, by contrast, were still equipped primarily with bolt-action Arisaka rifles, with limited numbers of Type 100 submachine guns that fired the relatively weak 8mm pistol cartridge. The disparity became brutally apparent in the savage fighting on islands like Tarawa, Saipan, and Peleliu. In the confined spaces of bunkers, jungle trails, and cave systems, American troops with Thompsons could deliver overwhelming firepower at close range, often deciding engagements before Japanese soldiers could effectively respond with their bolt-action rifles. After-action reports from Japanese survivors consistently mentioned the psychological impact of American automatic weapons fire, the terrifying volume of bullets that seemed to come from everywhere simultaneously. The Thompson itself was a marvel of American manufacturing, though also notoriously expensive and complex to produce. The M1928A1 variant that saw early service required extensive machining, with the receiver milled from a solid steel forging. The bolt was a massive, precisely machined component weighing nearly 2 pounds. The trigger mechanism was complex, allowing selective fire between semi-automatic and full-automatic modes. The barrel required precise rifling and chrome plating. Every component reflected American industrial capabilities, abundant steel, precision machine tools, skilled workers, and rigorous quality control. By 1944, the United States had simplified the Thompson design to ease production. The M1 and M1A1 variants eliminated some of the most complex features, removing the drum magazine capability, replacing the intricate cuts compensator with a simple barrel extension, and simplifying the actuator mechanism. Even in simplified form, however, the Thompson required manufacturing capabilities that were straining Japan's degraded industrial base to the breaking point.
A desperate undertaking.
The project to copy the Thompson was initiated in March 1944 at Kokura Arsenal on Kyushu, one of Japan's major military production facilities. By this stage of the war, Japan's industrial situation was becoming desperate. American submarines had devastated merchant shipping, strangling the flow of raw materials from conquered territories. Strategic bombing by B-29 superfortresses had begun targeting Japanese industrial facilities. Skilled workers were being conscripted for military service or dying in combat. Machine tools were wearing out with no possibility of replacement. Quality control was deteriorating as experienced supervisors were replaced by hastily trained workers. The Arsenal's director was Colonel Yamamoto Kenji, a 53-year-old career ordnance officer who had overseen weapons production since the mid-1930s. He was a competent administrator but increasingly overwhelmed by impossible demands from Tokyo. Produce more weapons with fewer materials, less skilled labor, and under constant threat of air attack. When the directive came from Imperial General Headquarters to develop Japanese production versions of captured American weapons, including the Thompson submachine gun, Yamamoto understood this was as much about demonstrating fighting spirit as achieving practical results. The technical lead was assigned to Chief Engineer Nakamura Hiroshi, a 42-year-old weapons designer who had studied mechanical engineering at Tokyo Imperial University before joining Kokura Arsenal in 1928. Nakamura had worked on various weapons projects throughout his career, including the Type 100 submachine gun that was currently in limited production. He was experienced, technically competent, and increasingly pessimistic about Japan's ability to match American manufacturing quality. When Colonel Yamamoto showed Nakamura the two captured Thompson M1 submachine guns that had been sent from New Guinea for study, Nakamura felt a familiar mixture of professional admiration and despair. The weapons were beautifully made with tight tolerances and superb finish. They represented manufacturing capabilities that Kokura Arsenal had possessed in 1940 but no longer maintained in 1944. "We are to develop Japanese production versions within 6 months," Yamamoto told him, cigarette smoke drifting in the afternoon heat. "The General Staff believes that equipping our forces with weapons equivalent to American automatic arms will help offset their material advantages." Nakamura said nothing. But privately, he thought this reasoning was backwards. The material advantages were precisely what enabled American weapons production. You couldn't manufacture Thompsons without the steel, machine tools, skilled workers, and industrial infrastructure that Japan no longer possessed in adequate quantities. Documenting excellence, confronting limitations. Nakamura assembled a team of 8 engineers and technicians, all that could be spared from other urgent projects. His deputy was Suzuki Takeshi, a 34-year-old engineer who had worked on the Type 100 submachine gun and understood automatic weapons design. The team also included Watanabe Isamu, the Arsenal's chief metallurgist, master machinist Kobayashi Hideo, who possessed decades of experience, and several younger technicians for documentation and testing. The team began with complete disassembly of both captured Thompsons. The weapons were M1 variants, the simplified version adopted in 1942. Even in simplified form, they were substantially more complex than the Type 100 submachine gun that Nakamura's team had experience manufacturing. The Thompson M1 operated on a simple blowback principle. The bolt was not locked to the barrel during firing, but was held forward by a powerful recoil spring. When fired, the pressure in the chamber pushed the cartridge case rearward, which pushed the bolt rearward against spring pressure. The bolt's mass and the spring's resistance delayed the rearward movement long enough for chamber pressure to drop to safe levels. The bolt then extracted and ejected the spent case, compressed the recoil spring, and was driven forward by the spring to strip a fresh cartridge from the magazine and chamber it. This operating principle was mechanically simpler than the locked breech rifles that Nakamura's team had experience with. But the Thompson's execution was sophisticated. The bolt was a massive, precisely machined component. It had to be heavy enough to resist opening prematurely under the .45 ACP cartridge's chamber pressure. The receiver was machined from steel, with close tolerances required for the bolt to reciprocate smoothly. The barrel had to be precisely rifled and properly secured to the receiver. The magazine well and feed mechanism required careful geometry to ensure reliable feeding. The bolt weighs approximately 680 grams, Suzuki reported during an early team meeting in April 1944. This mass is critical to the weapon's timing. Too light, and the bolt will open prematurely, causing dangerous casehead separation. Too heavy, and the cyclic rate will be too slow, and the recoil spring may not have sufficient force to reliably chamber rounds. The dimensions and weight must be precise. The receiver presented its own challenges. The Thompson's receiver was manufactured by machining a steel forging. Material was removed until the correct internal and external shapes were achieved. This process required substantial machine time on lathes and milling machines, using sharp cutting tools and skilled machinists. It was expensive and time-consuming, which is why the United States had developed the M3 grease gun submachine gun using stamped sheet metal construction. But the M3 design wasn't available to Japanese engineers, who only had the Thompson to study. Watanabe Isamu conducted metallurgical analyses of the Thompson's components. Using microscopic examination and hardness testing, he determined approximate steel compositions and heat treatment procedures. The bolt appeared to be manufactured from medium carbon steel, heat-treated to approximately 35 to 38 Rockwell C hardness. Hard enough to resist battering and wear, but tough enough to avoid brittleness. The receiver was similar steel, perhaps slightly softer. The barrel was high-quality ordnance steel, properly rifled and heat-treated. "We can approximate these steels," Watanabe told Nakamura, "but I must be candid, our steel quality has deteriorated significantly since 1942. The steel mills are receiving lower-grade raw materials due to shipping losses. Alloying elements are being substituted or reduced to conserve scarce materials. Quality control has suffered as experienced workers have been conscripted. I cannot guarantee that steel we receive will have consistent properties." This was exactly what Nakamura had feared. The Thompson's reliability came partly from consistent manufacturing with quality materials. If Japanese copies used inconsistent steel, they would have unpredictable performance and durability.
Manufacturing under siege. By May 1944, Nakamura had developed a manufacturing plan that attempted to work within Kokura Arsenal's degraded capabilities. Receivers would be machined from steel forgings supplied by the Yawata Steelworks. Bolts would be manufactured in-house, machined from forged steel blanks and heat-treated in the arsenal's furnaces. Barrels would be produced using existing rifling equipment. Small components would be manufactured from whatever materials were available. The plan was based more on hope than realistic assessment, but Nakamura had no alternative. The political and military pressure for results was immense. Failure to demonstrate progress could be interpreted as defeatism or insufficient fighting spirit, potentially resulting in reassignment, disgrace, or worse. The steel forgings arrived from Yawata in late May, and quality problems were immediately apparent. The forgings varied significantly in dimensions, requiring excessive machining to achieve correct sizes. More seriously, the steel quality was visibly poor. Microscopic examination revealed inclusions, voids, and inconsistent grain structure. This reflected the degraded state of Japanese steel production, lower-grade iron ore, reduced alloying elements, worn-out furnace equipment, and exhausted workers. Master machinist Kobayashi was assigned to manufacture the first receiver. Kobayashi was 61 years old, one of the arsenal's most experienced craftsmen, trained in the precise standards of pre-war Japanese industry. He studied the American Thompson repeatedly, took detailed measurements, and then began machining the first Japanese copy. The work proceeded slowly. Kokura Arsenal's machine tools were suffering from deferred maintenance and excessive use. Cutting tools were dull and couldn't be replaced. Tool steel was desperately scarce.
Kobayashi had to make multiple light cuts where he once would have made single heavy cuts, dramatically increasing machining time. Power outages occurred regularly as American bombing disrupted electrical supply, halting work unpredictably. By late June, Kobayashi had completed the first receiver. It was recognizably similar to the Thompson, but clearly inferior. The internal surfaces were rougher, showing visible tool marks. The tolerances were looser. The bolt had noticeably more play than in the American original. The external finish was crude, with an uneven parkerizing that provided minimal corrosion protection. The bolt manufacturing was assigned to another skilled machinist, and similar problems emerged. The steel's inconsistent properties made heat treatment unpredictable. Some bolts came out of the furnace too hard and brittle, others too soft. The weight varied by as much as 30 grams between bolts, which would significantly affect the weapon's timing and cyclic rate. Barrel production proved challenging. The rifling equipment was designed for rifle barrel production and had to be adapted for the shorter, heavier submachine gun barrel. The rifling process, cutting or button forming the spiral grooves inside the bore, was imprecise, resulting in barrels with inconsistent groove depths and twist rates. Without chrome plating capability, the barrels would wear more rapidly than American originals.
Air raids and desperation. On June 15, 1944, the project suffered a major setback when B-29 bombers struck Yawata Steel Works in the first strategic bombing raid on the Japanese home islands launched from bases in China. The attack disrupted steel production and damaged facilities, further degrading the quality and consistency of materials that Kokura Arsenal would receive. The psychological impact on Nakamura's team was significant. Until then, the home islands had been relatively safe from air attack. Now, the reality of strategic bombing and Japan's inability to effectively stop it became undeniable. The underground workshop where the Thompson project was housed had been excavated months earlier as a precaution, and now that precaution seemed prescient. By mid-July, Nakamura's team had manufactured enough components to assemble their first prototype, designated the Type 4 submachine gun internally, following the Japanese calendar system, where 1944 was year 2604. It looked vaguely like a Thompson, but was clearly a crude approximation. At approximately 5.2 kilograms loaded, it was significantly heavier than the Thompson's 4.8 kilograms. The finish was rough, components fit together loosely, and various details differed from the original due to manufacturing limitations. The test firing was scheduled for July 28, 1944, at Kokura Arsenal's underground testing range, a reinforced concrete tunnel excavated into a hillside to provide protection from air attack. Nakamura brought his engineering team, along with Colonel Yamamoto and several military observers from Tokyo. The test shooter was Sergeant Tanaka Yoshio, an experienced soldier who had fought in China and possessed extensive small arms familiarity. They had 30 rounds of Japanese-manufactured .45 ACP ammunition, a new production item itself, as Japan had never previously manufactured this American cartridge in quantity. Tanaka loaded a 20-round stick magazine, chambered around, and fired a single shot. The gun discharged with a heavy boom, and the empty case ejected. He fired a second round, then a third. The fourth round fired, but the fifth round failed to chamber. The bolt didn't strip the cartridge from the magazine cleanly, causing a feeding jam. They cleared the jam and continued testing. Over the next hour, the prototype fired approximately 15 rounds, but experienced frequent malfunctions: failures to feed, failures to eject, failures to lock the bolt back after the magazine was empty. Sometimes the bolt would stick partially open. Other times it would fail to fully chamber a round. The weapon's reliability was completely unacceptable. "The magazine geometry is incorrect," Suzuki observed, examining the feeding issues. "The feed lips don't present cartridges at the proper angle. The bolt face geometry may also be wrong. It's not reliably stripping rounds from the magazine. And there's excessive friction in the bolt's reciprocation. You can feel it cycling sluggishly.
Desperate iterations. The months from August to December 1944 were consumed by frantic iterations, conducted increasingly underground as American air raids intensified. Nakamura's team built 6 more prototypes, each attempting to address problems discovered in previous versions. They modified magazine geometry, adjusted bolt dimensions, changed recoil spring rates, and refined feeding angles. The work occurred against a backdrop of accelerating disaster. The Battle of the Philippine Sea in June had destroyed Japanese naval aviation. The fall of Saipan brought B-29s within range of the Japanese home islands. Strategic bombing intensified throughout the fall, targeting aircraft factories, steel mills, and arsenals. Kokura Arsenal itself was bombed on August 20, though the underground workshop escaped damage. Each prototype worked marginally better than its predecessor, but none approached acceptable reliability. The fundamental problems were systemic and worsening. Steel quality continued deteriorating as raw material supplies dwindled. Machine tools wore out with no possibility of replacement. Precision equipment from Germany or America was obviously unavailable, and Japanese machine tool production had collapsed under bombing and material shortages. Skilled workers were being conscripted or reassigned to more critical projects. Power supply became increasingly erratic. The ammunition situation compounded difficulties. Japanese production of .45 ACP cartridges was plagued with quality control problems. Cartridge case dimensions varied, affecting chambering and extraction. Propellant charges were inconsistent, causing some rounds to generate insufficient pressure to reliably cycle the action, while others were dangerously overcharged. Primers varied in sensitivity, causing occasional misfires or hangfires. By late 1944, Nakamura privately acknowledged what he couldn't openly state: the project was futile. Japan's industrial infrastructure had degraded to the point where manufacturing complex weapons to acceptable quality standards was becoming impossible. They weren't just trying to copy the Thompson, they were trying to maintain industrial capabilities that were actively collapsing under the combined pressures of strategic bombing, resource starvation, and labor shortages.
The final catastrophe. The 7th prototype, completed in late August 1944, had successfully fired approximately 380 rounds during testing, a significant achievement compared to earlier attempts, though still far below the thousands of rounds that American Thompsons could fire reliably. The weapon still experienced frequent malfunctions, but it at least functioned most of the time. A durability test was scheduled for September 3, 1944, to evaluate the prototype's ability to withstand sustained firing. The protocol called for firing 200 rounds, with cooling periods between strings of fire. Sergeant Tanaka Yoshio again served as the test shooter, despite lingering concerns about testing weapons of uncertain reliability. The testing began in the underground firing range, with Nakamura and his team observing behind a protective barrier. Tanaka fired the first magazine of 20 rounds successfully, though there were 2 failures to feed that required manual cycling of the bolt. The second magazine fired with similar reliability. By the third magazine, the weapon was becoming noticeably hot, and Tanaka reported that the bolt was moving less smoothly. The test continued through the morning. By round 150, Tanaka reported increasing difficulty. The bolt was binding during reciprocation, requiring more force to charge the weapon. Nakamura considered halting the test, but the pressure for results drove him to continue. Tanaka loaded a fresh magazine and resumed firing. He fired 2 rounds successfully. On the third round, there was an explosion.
not the normal report of a .45 ACP cartridge, but a much louder, sharper detonation accompanied by a bright flash. The bolt assembly, driven rearward by catastrophic overpressure, wasn't captured by the receiver. Instead, it flew completely out of the rear of the receiver, traveling backward at tremendous velocity. The bolt struck the concrete wall behind Tanaka with enough force to shatter, sending fragments ricocheting through the firing tunnel. Several fragments struck Tanaka in the face, one piece penetrating his left eye and destroying it. Tanaka collapsed, screaming. Blood poured from his face. The destroyed weapon lay on the firing line, its receiver cracked, the bolt mechanism gone. The barrel visibly bulged near the chamber. Nakamura rushed forward with others to help Tanaka, but his mind was already processing what had happened. An overcharged cartridge, almost certainly the result of quality control failure in ammunition production, had generated excessive chamber pressure. The bolt, which in a properly designed blowback submachine gun should be heavy enough to resist opening prematurely, had been too light, or the receiver hadn't properly captured it. Instead of containing the pressure, the weapon had effectively turned into a pipe bomb.
The end of illusions. Tanaka survived, but lost his left eye permanently. He also suffered severe lacerations across his face that left permanent scars. He was invalided out of military service and sent home to his village, another casualty of Japan's losing war. The Thompson project was terminated within days of the explosion. Colonel Yamamoto wrote a brief report attributing the failure to insufficient material quality and ammunition production difficulties. He didn't mention the fundamental impossibility of the task, that Japan's industrial base had degraded beyond the point where manufacturing complex weapons to acceptable standards was feasible. Nakamura was not punished, largely because everyone in authority understood that failure was inevitable. He continued working at Kokura Arsenal on progressively simpler projects as Japan's industrial situation deteriorated further. The arsenal itself was severely damaged by B-29 raids in 1945, and the city of Kokura was the original primary target for the atomic bomb that ultimately struck Nagasaki on August 9, 1945. Smoke and haze over Kokura that day caused the bombardier to divert to the secondary target. All prototypes of the copied Thompson were destroyed or lost during the final months of the war. No documentation survived. It was either destroyed during bombing or deliberately burned as defeat became inevitable. The project left no physical legacy except Tanaka's ruined eye and scarred face. Japan never successfully manufactured Thompson-style submachine guns. The Type 100 submachine gun remained in limited production through 1945, and desperate attempts were made to develop even simpler designs, like the Type 2 submachine gun, which used crude stampings and minimal machining. But by 1945, Japanese small arms production had collapsed to the point where military units were being issued bamboo spears and told to prepare for glorious death defending the home islands.
Lessons written in blood and defeat. The failed Thompson copying project stands as a microcosm of Japan's larger industrial and strategic failure during World War II. The project was undertaken not because success was likely, but because the alternative, admitting that Japan could no longer manufacture weapons equivalent to American arms, was psychologically and politically unacceptable. Nakamura Hiroshi survived the war and worked in Japan's reconstruction industries until his retirement in 1970. He rarely spoke about his wartime work, but in a private conversation recorded by his son in the 1980s, he reflected on the Thompson project. "We were trying to copy American manufacturing with machines that were falling apart,
steel that was barely adequate, and workers who were starving. It was impossible, but we couldn't admit impossibility. That denial, the refusal to honestly assess our capabilities against our ambitions, that characterized our entire war effort. The Thompson itself continued in American service through the end of World War II and into Korea, eventually being replaced by more modern designs. More than 1.5 million were manufactured, and they proved reliable and effective throughout their service life. The weapon's success came not just from John Thompson's design, but from America's industrial strength, abundant resources, precision manufacturing, skilled workers, and the logistical capability to deliver weapons and ammunition to troops across the Pacific. Japan's failure to copy the Thompson revealed the hollowness of militarist rhetoric about spiritual strength overcoming material disadvantages. Spirit couldn't machine precise receivers on worn-out lathes. Fighting spirit couldn't make inconsistent steel performed like quality alloy steel. Bushido couldn't overcome industrial collapse. The project's legacy, such as it is, lies in the lesson that Nakamura learned too late. Technological capability cannot be separated from the industrial, economic, and social systems that produce it. The Thompson submachine gun was not just a weapon design that could be copied from captured examples. It was the product of American industrial maturity, resource abundance, manufacturing expertise, and quality control systems. Without equivalent foundations, copying was futile. Sergeant Tanaka Yoshio lived until 1989, his scarred face and missing eye a permanent reminder of Japan's desperate, failing attempt to match American industrial power through force of will alone. In his final years, according to family members, he spoke occasionally about the explosion that blinded him, not with bitterness toward Nakamura or the engineers who built the faulty weapon, but with a kind of sad resignation about the futility of what Japan had attempted during those desperate final years of the war. The underground workshop where the project unfolded was sealed after the war and eventually forgotten. If it still exists beneath modern Kitakyushu, as Kokura is now known, it stands as an unmarked monument to ambitious failure, to the gap between what was desperately needed and what was actually possible, and to the hard truth that some achievements cannot be forced through determination alone, but require foundations that take generations to build.